So today we're going to continue looking at this freefall motion word problem where it's a ball being thrown up in the air at a speed of 15 meters per second. Today we're going to find the maximum height reached. Our first step is going to be to draw a diagram. So we have the ball in the general motion as well as the initial velocity equal to 15 meters per second. And this distance here is going to be the maximum height of the ball. And I also want to note that at the maximum height, the velocity is going to be equal to 0 because the ball is not going up or down at that exact moment. So this is going to be crucial to finding the maximum height. We can also draw a gravity vector, which is equal to negative 9.8 meters per second squared. And I just want to note that the up direction is equal to positive. That's our coordinate system we're using. Step 2 is going to be identify the equations needed. So we're going to need the position equation here, and then we're also going to need the velocity equation. So now we have everything we need to solve. So if we look at the position equation, we know the initial height, yo, we know the initial velocity, and we know the acceleration. We don't know time. So we're going to need to use the velocity equation first to find the time. So we can write down the velocity equation here, and then we can plug in the values we already know. And we get this expression here. Then we can bring 15 to the other side to isolate for t, and then we can multiply both sides by negative 9.8 meters per second squared. And so we isolate for t and get this expression here. And then we can divide the amplitudes and divide the units, and we get the final answer here, which is 1.53 seconds. So I just want to note this is going to be the time that the ball is going to be at the maximum height. So now that we have this, we can plug it into the position equation. And if we plug this in with our other values here, we get this expression here for the maximum height. And then we can compute the first term here, multiplying the amplitudes and the units. And then we can also compute the second term, multiplying the amplitudes and the units there, giving us this expression here. And then we can do a simple addition and get the final answer. And so we can plug this into our diagram at the top here. The maximum height the ball is going to reach is going to be 34.42 meters.